Hey, welcome to Math. Mr. Jorgens. Here is 4.3. It's part 1. It's on parallel lines. We're going to be talking about this word parallel today. Make sure you're paying attention. There will be a few questions for you along the way. Alright, so we're going to start out with our definition of parallel lines here today. Two lines are parallel. That's our big word. If both these things are true. 1, the two lines have the same slope. And 2, they would never intersect on a graph. Now, in terms of intersecting on a graph, it's not just the part you see. If this is our coordinate plane, if that's line A and this is line B, those are not parallel lines because even though they don't intersect or cross on this graph, if we extended by the arrows, they would eventually cross, right? So this would be a case of not parallel. So we would need two lines that would go on forever in both directions without crossing. Like those two lines would go on forever, the two black ones there. Without crossing, they have the exact same slope. Just one line just shifted up or down. That would be an example of parallel lines. All right, let's take a look at example 1 here. Which of the following three lines are parallel? So this blue line, I'm going to call it line A. The red line, I'm going to call it line B. And this green line, I'm going to call it line C. So we know that two lines are parallel if they have the same slope and don't intersect on the graph. So which of those two lines would be parallel? Yeah, hopefully you're able to identify that there. It would be A and B are parallel. And the reason why is because these two lines, they're going to go on forever in both directions and never cross each other, right? We have A and C crossing right there. We have B and C crossing right there. So A and C cross each other, B and C cross each other, but A and B would be the parallel lines here. All right, let's take a look at our second example here, and it's going to hit at the second half of that definition. So we kind of just looked at example 1 was all about two lines that would never cross. This one's going to be about two lines that have the same slope. So we want to know which of the two lines are parallel. We have line A, which is y equals 4x plus 7. We have line B, which is y equals 3x plus 7. And we have line C, which is y equals 4x minus 2. Now we're going to take a look at which of the lines are parallel here, meaning they have the same slope. Just a quick refresher, these lines are all in y equals mx plus b form. And we've learned before in section 4.1 and a bit in chapter 3 that letter m, that's going to be our slope here, right? So we're going to take a look at those lines and compare the slopes, our m. And the question is, which of those lines have the same slope, meaning that they're parallel? So select the two parallel lines and enter your answer when you're ready. So taking a look at our slopes, line A and line C both have a slope of 4. So since line A and C have the same slope, lines A and C are parallel. All right, let's take a look at a third example here. We're going to write the equation of a line through the point 1, 4. That's parallel to the equation y equals 3x plus 7. So if I'm going to take a look at this problem here, I know I want to write the equation of a line. It's kind of like our instructions here. So writing the equation of a line, it doesn't tell me what format to use. So if I'm not told the format, usually I'm going to pick slope-intercept form. That's typically kind of the easiest format. So I'm going to start out by writing y equals mx plus b over here on the left. Now I know I want the line to go through the point 1, 4. So it's giving me an x and a y. And I also know that it's giving me that it's parallel to the line y equals 3x plus 7. And I know parallel lines have the same slope. So I'm going to be using m equals 3 as my slope here, since in y equals mx plus b, m would be 3 in this equation. So just pulling those pieces out, I know that in my equation m is 3, and I'm going to try to find b, because in y equals mx plus b, I'm always putting a number in for m and a number in for b, but I can't find b directly from this information. So temporarily I'm going to use the fact that x is 1 and y is 4 in order to help me find b. So what I'm going to do is I'm going to plug in the pieces. I know that my y value is 4, so I'm going to plug that one in for y. And I know my m value is 3, so let me go ahead and plug that in for m. And my x value is 1. And then plus b here, and I'm trying to find my b, yeah? So I'm going to solve that equation for b. So 3 times 1 makes 3. And I want 3 plus b equals 4. So go ahead and solve it out really quick. 3 plus b equals 4. If this is my equation, go ahead and solve that equation for b and enter your answer when you're ready. So 3 plus 1 makes 4, or I can subtract the 3 over. Either way, I find that my b value is 1. Now that I know that b is 1 and my m is 3, I can go ahead and write my equation of the line y equals 3x plus 1. Again, I was just temporarily using my x and y in order to help me find the b, right? So take a look at this because you're about to do it for yourself. A similar example on the last screen. I plugged in my m, and then I temporarily used x and y here and plugged them in order to find b. And then once I have my m and my b, I use those values to write my final equation, y equals 3x plus 1. You're going to try something very similar on the next screen. All right, so go ahead and try this one on your own. It's our last problem of this video. Example 4, we're going to write the equation of a line through the point 2, 5 and parallel to y equals 4x plus 3. Just to kind of set you up here, we're going to be using the formula y equals mx plus b. I know from my point that my x value is going to be 2 and my y value is going to be 5, so I can kind of jot those down, and we're going to temporarily use those. And then from my parallel equation, I know it's parallel to y equals 4x plus 3. So I can pull out my m from there, and I'm going to kind of permanently use that m throughout this problem. So go ahead and use those values, solve it for b, and then you're going to write the equation y equals mx plus b for the equation of the line that goes through the point 2, 5 and is parallel to y equals 4x plus 3. All right, let's take a look at this one. We can plug in our values to solve for b. So 5 equals 4 times 2 plus b. 4 times 2 makes 8, and then moving the 8 over, I'd have negative 3 as my b value there. And so then once I have my b value as negative 3, I can plug that in along with my m value of 4, and I get y equals 4x minus 3. Hopefully you were able to follow along with that one. We're going to talk about a new word called perpendicular on the next video.